machine at a soft drink factory is set to produce bottles of cola with a mean volume of 600 millilitres and a standard deviation of 2 millilitres. Quality control regularly tests samples of 100 bottles to see if the mean has changed. One test batch has a mean of 600.4 millilitres. Test at the 5% level whether the mean has changed, assuming, of course, that the standard deviation has not. So we know that our bottles follow a normal distribution with a mean of 600 and a standard deviation of 2. So I'm going to set up a null hypothesis, which is that mu is equal to 600. That's the hypothesized mean. We're just seeing if it's changed, so the alternative is that mu is not equal to 600, which is going to give us a two-tail test, which needs to be at the 5% level. So if we look at that, that means that since we're going to use the standard normal, that we're going to have a value here and here so that we have 2.5% at either end. So you can find these sorts of things straight from a calculator. I'm going to use my calculator. There'll be a similar app on any calculator you have these days. So on mine I go for an inverse normal, and I'm going to put the tail setting to left and have a probability of 0.025 because it's 2.5% at either end. Note that the parameters for the standard normal are already in here. And that is negative 1.96. And this is 1.96. So my critical region is here or here. So that's my critical region for the test. So what I need next is my test statistic. And the test statistic is x, and it's equal to x bar take away mu divided by the standard deviation over root n, where n here is the number of bottles in the test. So we're going to need to calculate that, and the x bar was the mean from our sample. The mu was the hypothesized mean of 600. We know that the standard deviation is 2 over the square root of 100. So let's calculate that and see what happens. So I've got 600.4, take away 600, divided by 2 over the square root of 100, which of course is 10, and that actually gives me 2. Which means that our test statistic is here in the critical region. We would therefore have reason to believe at the 5% level that we should reject the null hypothesis and that the mean has changed.